We come now to our last of the three main and basic gates. So we've introduced not, and now we're going to introduce something called the OR gate. Now, there are some areas where new students to this material can get these concepts confused. So we'll try to spell it out in this video. What does OR actually mean? OR doesn't mean both values or inputs, all values have to be true. So your output is then true. OR simply means only one of your input value needs to be true. The rest can all be false and the output will be true. Okay, so let's have a look and let's spell this out very, very carefully. So the mathematics, again, let's start with the mathematics. For the OR gate, the mathematics is a sum. And we'll talk that through in a second. Remember, with AND, it was the multiplication of the two values. So what's the difference here? Well, look at this formula here and let's put it through combinations of values and see if we can pick it apart to make sense. So I've got my two input values, A and B, and I've got my output value here, right? And let's go through all the obvious combinations. I can have 0, 0, 0, 1, 1, 0, and 1, and 1. But the mathematics involved here, in order to get this OR gate, is this. X equals A and B. Okay, so let's have a look at how this works. A and B as a sum, not as a product, not multiplied, but added. So if you add 0 and 0, you get 0. If you add 0 and 1, you get 1. If you add 1 and 0, you get 1. If you add 1 and 1, interestingly enough, you get 1, 0. Right? Now, this last case creates complications for our circuits, and we have to talk about it because this is 2 bits, and these are all 1 digit or 1 bit. So we'll come back to that later. The bit I want you to have a look at is the fact that this is just adding the two values, right? Let me use a different color. There we go. So 0 and 0, 0 plus 0, 0, 0 plus that, 1 plus 0 is that, 1 plus 1. But this is 1, 0. So let's just focus on this and what we do in this table. What we actually do with the OR gate is we make a decision. And the decision is that we are only going to pay attention to one of these digits. So have a guess which one I'm going to pay attention to. Did you guess correctly? Let's scrub this out. Bear with me a second. Right. Okay, so did you get the correct answer? So I'm not going to deal with both digits. In order for my maths and everything to work, the only digit I'm going to deal with is the second digit. I'm actually going to say 1 plus 1 equals 1, right? That is mathematically, we know it actually equals 1, 0, not 1. But what does this last line here, why have I reduced this combination to 1? Spell that out a bit, okay? Because this is where we come to, so this is the OR gate, right? And what we're saying is that 1 plus 1, we're going to say is 1. Okay, but we know when we add 1 plus 1, we get 1, 0. So why are we ignoring this 0 here? It's because what we do with the mathematics is we interpret the mathematics. We make a decision. And computer scientists have made the decision that logically, we are going to interpret this as a logical concept, right? If one is true and another one is true, then we will output true. And it's that interpretation, that logical interpretation, which means that when you look at the actual maths, we discard that 0. We ignore it. quite tricky concepts if you're completely unfamiliar to them. Let's have a look at what the gate looks. It's a curve with a kind of half circle attached to it, with your input values going in here and your output here. And remember, it's now logic. The mathematics which supported it, which was A plus B, we have to, when we both are true for our inputs, or all of them are true, we don't just end up with huge binary numbers over here, which is the sum of all these numbers, right? Imagine you had 500 inputs into an OR gate. Doesn't mean that you're going to have a huge output because you're just adding them all together. All you do is, if the logic is, if one of them is true, then the output is true. So OR captures that ordinary concept of either or any of the values. So if any of these values are true, then the output is true. Now that is a step away from straight mathematics. Let me finish very briefly by a couple of notational things, okay? And it's worth just pointing out. So far, we've represented our mathematics with just the plus sign. So we had A plus B. But actually, another set of notations you might see if you trawl the internet is this upside down V, or this V, sorry, which is a point at the bottom and open at the top. That's another way of representing OR. And just by its natural contrast, because these gates often are seen together, the two ways of representing AND are A times B and A with that little V sign flipped over B. Now, in terms of what you're familiar with, if you're experienced and you're used to this notation, then feel free to use it. If you're not, you will find mathematically, although we have to play a little bit of interpretation for this one here, this maths luckily helps us and we don't have to fiddle with the maths in order to interpret this. But this one, if they're both true or all are true, it clearly exceeds a single digit. And we have to choose which digit we're going to deal with. This mathematically, though, is easier to deal with. And this is the notation I will stick to for the time being. But you're welcome to use this alternative one. It all comes down to the ease of use. Finally, let's just give it a simple example of an application. So imagine I have three sensors, right? A, B, and C. And these are light sensors. I pass them in to an OR gate. And what I want to do in my output is, say, trigger a little light of some kind. Okay, so I have OR, I have that, and that. And they're going in through an OR gate. How does it work? How will it work? Well, what will happen is if they're all switched off and no lights coming in, right? Or no activity, could be motion sensor, there's no activity, they're all zero, they pass zeros in, right? Nothing's going to come in. But if one is triggered, it sends a 1 down here. It doesn't matter if the others are switched off, because the OR gate only needs one of the inputs to be true, and then it will trigger the light. So if you had a bunch of sensors set around your building, or motion sensors, and you used an OR gate, that would be a clever way of triggering a security light, for example.